When COVID first arrived in Aotearoa, New Zealand, near the beginning of 2020, scientists working at ESR already understood the importance of looking at the genetic fingerprints of viruses.
We were trying to work on infectious diseases specifically from the genomics angle, where we could sequence basically every notifiable disease within the country.
We thought that it would be extremely beneficial if we had genomic data to better inform our response to COVID-19.
Viruses adapt and change very quickly, which is useful in knowing both how to fight the virus as well as where it might have come from.
So when animals and plants take thousands of years to infer changes like that, viruses change when they're transmitted from one person to the next. So they mutate very rapidly, and by comparing the mutations between each genome, we can then estimate a phylogenetic tree, which is a bit like a family tree. It shows how the genomes are related to each other. And so if they're genomically very, very similar or even identical, you could conclude the people that had those viruses were transmitted to each other.
Researchers were assisted by homegrown technology, which allowed for the virus to be analysed quickly. This became the standard protocol around the world.
Two scientists at Massey University in New Zealand were able to develop a really rapid sequencing protocol, and this allowed us to generate virus genomes rapidly.
So if you get one of those swabs stuck up your nose, they look for one very small part of the virus. What they've done is they've chopped the virus up into about 300 different pieces. They then put it into a sequencing device that can read all those copies, and then you can read the entire genome of the virus.
We were able to collect clinical samples and have a genome within just a few hours of the sample being collected.
A month after the first case arrived, New Zealand's borders were effectively closed. By early April, everyone arriving had to isolate in MIQ facilities. This provided scientists with a unique advantage.
We were in this unique situation as New Zealand because of the approach we had taken. We were sequencing every single case, and we could link that case to the one before.
Because of this, scientists in Aotearoa were in a unique position to study COVID in ways that were impossible elsewhere in the world.
There was a lot of debate about how COVID was transmitting. A study from the US implicated the filtering that we have in airplanes. They will filter out any particulate matter, and it's absolutely fine.
But what we were seeing in New Zealand was a different story. We were able to actually show that that wasn't always the case.
It was a flight that had come to New Zealand, and what was really strange about that is that quite some people on that flight had a late onset of the disease.
The New Zealand study was the first to conclusively show transmission on a flight.
We're able to point exactly to who was the index case, who had got infected, and whether they'd been infected on the plane or subsequently in the managed isolation facility.
There was lots of cases that were genomically linked, where the only contact these people had was during the flight to New Zealand.
Another discovery involved the transmission of COVID between people who had never even been in the same room together.
The only time we could identify that there'd been transmission event possible was that when the nurse opened the next door of that hotel room and the person stepped out of their hotel room, were swabbed by the nurse as well and stepped back in. We actually had an engineer look at these rooms to see whether or not they were linked, and the only thing that you found was that there was a net positive air pressure inside the room. So when you open a door, air flows out along with virus particles suspended in that air.
Slowly but surely, the genomics, together with the epidemiology, started providing evidence that airborne transmission was the major mode of transmission. Almost everywhere in our pandemic response, there is a piece of genomics.
With New Zealand having among the lowest rate of deaths from COVID in the entire world, researchers hope that the lessons learned from the pandemic won't be forgotten, even if we seem keen to move on.
We were able to keep the virus out of the country for a long time, and the information we gained from genomics helped us to do that. It shouldn't stop at COVID-19. We are now sequencing genomes of influenza virus and RSV and other things that are circulating in our communities.
The one thing that I think we could learn from COVID is that this can also apply for other diseases. We can do a lot better at understanding how and where it's spreading and where we can put in place interventions to stop that.